Alright, today we're going to be talking about motor drives. So, a little bit of comparison with motor drives is, you can see the magnetic starter over there. So, they both can turn a motor on or off. They both can provide overload protection, but only a motor drive can provide speed control, stopping methods, temp control, etc. Magnetic starters are not something that can control those things. Motor drives. A motor drive is an electronic unit designed to control the speed of a motor using solid-state components. They can be either AC or DC. Both types of drives are used to control motor direction, speed, and acceleration or deceleration time. AC drives are the most common. Smaller AC drives, that's going to be less than 3 horsepower, can be powered by one phase, 115 volts or 230 volts, and they can control a 3-phase motor. They're ideal for residential and light commercial HVAC systems. Whereas magnetic motor starters, they're used to turn motors off and on, and they provide overload protection. They work well in basic on-off motor control, and the price remains the same no matter the horsepower. So pretty much you're going to be spending the same on a magnetic motor starter, whereas if you start getting on up in horsepower for a motor drive, they can become a little more expensive. So here's just a few pictures of some motor drives. A major advantage of using a motor drive instead of a motor starter is that the drive offers different motor speed control. So a motor speed control, potentiometer, is a variable resistance electric device that divides voltage proportionally between two circuits. A potentiometer, where it's 5K ohms to 10K ohms, can be connected directly to the motor drive. So in our lab, you'll see us connect a potentiometer, and as we twist that potentiometer, it will make the motor go faster or slower depending on the parameters that we put in. A motor drive also allows a voltage or current input to control the speed of a motor. This means that depending on the settings of the drive, the motor will operate at a certain percentage when its parameters are met. Programming motor drives. A motor drive is programmed by setting various parameters. Basic motor drives can contain approximately 30 parameters, where the advanced drives, they might contain up to 100 parameters. So what is a parameter? You hear that word a lot. Parameter is just a fancy word for something that defines a system and its operation. So a parameter is something that you're going to set to define that motor control system. So there's some parameters you might see. That's going to be motor nameplate info, acceleration time, motor stopping methods. So you're going to set these parameters depending on what application you're having to use, whether it be in lab or in a job or whatever you're doing. You're going to have to set these because that motor or that circuit cannot bypass these parameters. And then you'll see some fault codes. When we use drives, troubleshooting might be more time consuming than when we use starters. So for this reason, motor drives will detect and display common circuit faults. Some common faults you may see are power loss, over voltage and under voltage, loss of phase, phase to ground short. So with whatever drive you're working with, you need to be familiar with the faults you may see and what would cause those faults, because that's a good troubleshooting technique, is to look for your faults first. AC motor drives. They're often referred to as variable frequency drives. That's what we're going to be working with. That's what you'll hear us call them, VFDs. Adjustable frequency drives, inverter drives, vector drives, direct torque control drives, and closed loop drives. Regardless of what somebody calls it, its job is to convert incoming supply power to an altered voltage level and frequency that can safely control the motor connected to the drive. So, no matter what you hear it called, that's its job. Converters and inverters. A converter is an electronic device that changes AC voltage into DC voltage. An inverter, something we see more often than a converter, is an electronic device that changes DC voltage into AC voltage. So, for example, an inverter would be used with renewable power. So, if you have a wind turbine and that's direct voltage, that has to be inverted into AC voltage before it can be put on a transmission line. Most important part of a motor drive, the inverter is, because the inverter determines the voltage level, voltage frequency, and amount of current that a motor receives. And motor stopping methods. We've been over this in a past chapter, but just to touch back on these, a drive is going to use various stopping methods. Using a drive to apply a braking force helps keep maintenance at a minimum because there are no parts that come in contact while stopping. So going over just the four most common is ramp stop, and that's a stopping method where the level of voltage applied to a motor is reduced as the motor deaccelerates. This is normally the default stopping method, so that is what would normally be set as the stopping method straight from the factory. So that's factory settings. Coast stop is when the motor drive shuts off the voltage to a motor, allowing the motor to coast to a stop. In most environments, that's a pretty good one because once you turn power off to the motor, it just literally stops whenever all the power is reduced. DC brake stop is when a DC voltage is applied to the stator winding of a motor after a stop command is entered. And soft stop, also called S-curve, is where the programmed deacceleration time is doubled and the stop function is changed from a ramp slope to an S-curve slope.